Before we start getting into some of the problems that you might have to do with functions in the functions topic, there's a few key bits of baseline information that you probably need to know. And the most important one of that is the definition of a function. And so a function can be defined as an expression that assigns exactly one output to every input. And that may be a bit of a confusing phrasing, but it's important that this phrasing is used because that is the correct phrasing. And I'll give a few examples of some things. I'll just draw axes, x, y. And here are 4 examples. Not all of these are functions, because not all of these match our definition. In here, let's have a look. As we go along from here, go here, we can notice that for every input, which is an x value, there is only one output, which is your y value. For example, say this is 2x minus 1. It's very clear and obvious that, say here at minus 5, there can only be one answer. There can only be one answer. So it is a function. And here, let's see, as we go along left to right, say this is x minus 1 squared minus 2. At minus 3, there can only be one answer. So it is a function. But here, what looks roughly a bit like, well, we could say, if I move this down a bit and it'll be easier to show, y squared equals x. Well, y, then, so if we put in, say, 1, y could be 1, but it could also be minus 1, because minus 1 squared equals 1 and 1 squared equals 1. Both of those y values would give you that same x value, so it is not a function. Then for this last one, we have a circle on the graph, and let's say it's x squared plus y squared equals 16. And at this point, here, this is both, say, x equals 3. Then so if we do some rearranging, we get this. So that means y, and because that's a squared, it'll be plus or minus root 7. So that's two different answers for y, and yeah, and so this is also not a function. And I hope now that makes clear what is meant by when you assign exactly one output to every input. What this essentially says is, we put in an x value, there can, according to the expression, there can only be one y value for that x value. You can't get confused with there being perhaps the same y value for different x values. That is allowed, like in a quadratic. And that is actually what we call a many-to-one function. Because it obeys the rules, because for every x value there can only be one y value, but perhaps for two different x values they both can lead to the same y value. But the importance is it can only lead to one y value. And then that, if we call that many to one, then this one would have to be 1 to 1. And then this one here, just have a look. With one x value, we can get more than one y value. So that's 1 to many, and we'd call it a relation. And then this one here, because we could also get those same points on the other end, that becomes a many to many relation. And now you can, and also how to identify if something is a function. You use the vertical line test. If you use a vertical line like this, and then you move it along the graph, and it will never cross more than one point on the graph at the same time, it's a function. Like so. Both are functions. Now we get here, oh, we're cutting it at 2 points, not a function. Oh, cutting at 2 points, not a function. And additionally, if you want to check if something has many inputs, you can use a horizontal line test. See, no, it's a 1 to 1. Oh, many to 1 because it's crossing more than once. 1 to many because it's only crossing once. Many to many because it's crossing more than once. In the next video, we will start to look at things like domain and range and some other stuff that you can do with functions. But this is just some essential foundational knowledge for functions.